We are very excited to be here to discuss about our work on developing this certification framework for uh, responsible AI in the context of generative AI. Uh, this is work in collaboration with a lot of people, also from Amazon, uh, and also like people from TPI and Stony Brook and UIUC. So we will have like two parts of the talk, where the first part would be Alvin. He will be talking about this conceptual framework of responsible AI. And in the second part of the talk, it would be a bit more technical in the sense that I will be discussing the technical details of this certification framework. So yeah, I think we like Alvin, like maybe you can go ahead.
Okay, great. Thank you very much, Gagandeep. So yes, just to kind of before I start here, I actually used to actually work at Nokia. I used to work at the Nokia Research Center actually in Beijing, almost like maybe 15 kind of years ago. So Nokia is very dear to my heart. So thank you for inviting myself and Gagandeep to this talk. Gagandeep, can you change the slide?
Can you repeat?
Can you switch the slide? Can you advance the slide?
Okay.
Is the slide advancing?
To me, it is advancing.
Okay, I don't know, on my screen or so, it seems to be frozen on the first screen.
Oh.
It's okay. I can probably go to the PowerPoint and then I can tell you when to change.
Okay.
Okay. So. Okay. Go to slide number 3.
Yeah, we are there.
Okay, great. Yeah. So basically, before Gagandeep talks about the kind of the certification and LLM safety that he'll be talking about, I want to kind of like go a little bit above and like figure out here that we have this motivation and problem where we know that now with AI it has dramatically affected every industry. And if I take a quote like from Spider-Man, right, with great power comes great responsibility. So everybody knows that in organizations, we need to have responsible AI, but however, it's not very clear in terms of how to be able to do that. So what we are going to present here is a kind of a conceptual framework for advanced and responsible AI. And this conceptual framework was published, slide number 4.
Okay.
So this particular conceptual framework was published recently at the IEEE ethics conference that was in Chicago. And basically, this framework consists of 4 phases here. The first one is called stakeholder needs, so understanding diverse perspectives on AI risks and operations. The second is education, developing workforce skills through training programs. The third is policy, establishing rules and governance for AI use. And the fourth one, which Gagandeep will go into very much more detail, is on certification, ensuring that the AI models meet ethical safety standards. Next slide.
Yeah.
So for stakeholder needs and perspectives, what do we actually need to do here? So companies, what they need to do is that they need to form a stakeholder group. You got to go ahead and ask each department, how they use AI and what are the risks of AI. And so for doing this, what companies can do is give a survey of questions, asking people their AI readiness, how does each person use AI, and what is the impact of AI. Also, in addition, is to form focus groups to understand the AI safety readiness and knowledge of stakeholders. So what we did is that last year in December, along with the UIUC Geese College School of Business, we did something at DPI, which was a generative AI for managers workshop. So we wanted to get people who are managers and let them discover how they can use Gen AI, for their particular line of work. So some of the questions that we asked them in this kind of stakeholder kind of needs is that, for example, what specific areas or processes in your company is Gen AI currently being used? And another question that we asked was, what is your current knowledge of Gen AI? And so we see here that there's a very different wide spectrum in terms of particular areas. So for most of them, it's using for innovation, right? And I'm sure you use as well ChatGPT to be able to ask particular questions in terms of for innovation, in terms of operational efficiency, customer support. And we can see here that for the current knowledge of Gen AI, some particular managers have no knowledge. They first time heard of this. Some of them are beginners, intermediates. So it goes through the entire spectrum. Next slide.
Yeah.
So basically, all departments, if you want to have a AI kind of strategy, responsible AI, you need to involve all the departments in the organization. And you need to embody design thinking principles that embody responsible AI practices. And it's important to note here that AI models, they're built by humans. So therefore, AI models are a reflection of the engineering that designed them. And companies need to build automatic testing and debugging tools from software engineering literature to detect and explain edge case biases. Next slide.
Yes.
So that is stakeholder needs. The next particular component is on education. It's very, very important that we have to educate the existing folks in the workforce and also for the new people that are entering into the workforce. Next slide.
Yes.
So in here, what we've kind of started doing is that we've tried to create this kind of framework called a responsible AI learning simulations. And what we intend to do is that we want to create workforce development programs in responsible AI. Now at DPI, we have a business unit called Pritzker Tech Talent Labs, PTTL, and that's essentially kind of what they're doing is that helping students, helping existing employees, and helping those that are coming into the workforce and that kind of knowledge of responsible AI. And what we want to do is create experiential learning programs. So we want to get students to understand the particular challenges that businesses are facing. So for example, we held a fintech forum back at DPI where we actually explored what are some of the business issues that fintech companies are happening and what are particular types of responsible AI that need to be done to be able to do that. Next slide, please.
Yeah.
So in addition to as well, what I mentioned about the such framework, also we need to create workshops for employees. So I mentioned already previously about the Gen AI workshop for managers. And then of course, employees and individuals need to take AI skills and leadership programs. So your organization, may have these type of, programs, or you can also take certification programs. So one of the things that we are working together with an organization, which is AI 2030, which is a nonprofit organization within 1871. They have a certified responsible AI leaders program, which basically, people, who want to get into leadership roles and they need to understand more about responsible AI, they take this kind of a 10-week kind of program. And then at the end, they get the certification that says they're a certified responsible AI leader that tells their management that they know they have the tools to be able to implement responsible AI in their organization. If you're familiar with IEEE, IEEE also has a certification program, which is called Certified as well. And also as well, there's responsible AI education. So for example, Infosys, which is a very popular IT company, has an Infosys Knowledge Institute. There's a Responsible AI Institute, which you might be familiar with. And they also have particular courses and education as well to let people understand more about responsible AI and how it affects your organization. Next slide, please.
Yeah.
Okay, so the third part of this conceptual framework is talking about the policy. So how do we establish rules and governance for AI use? Next slide, please.
Yeah.
So what's important here is that we have the AI, we have these responsible AI, but the thing is that how do we make it such that people will be able to use that? So we need to enforce particular rules, governance, and policies. And so one of the things that we're looking at is that we're looking at whether there exist responsible AI frameworks that have governance and policy, and how can a company create responsible AI governance and policy. So every particular organization will need to have their own particular policy, as well as creating federal and also state and urban city level policy too as well. But if you're creating the AI policy, some of the issues to address here involve, trust and transparency, ethical principles and guidelines, responsibility and accountability, address bias and fairness, safety and security, adaptability and continuous learning, legal and regulatory compliance. So for our team here, we look to Professor Lavarshni, who previously was at UIUC and is now at Stony Brook. And he was one of the policy kind of experts on this. In fact, he actually was a White House fellow who actually in 2023 helped to create that the Biden AI executive order. So he was responsible for implementing that type of that kind of policy. Next slide, please.
Yeah.
So also as well, in the U of I system, we have a IGPA, which stands for Institute for Government and Public Affairs. And basically this particular organization, which is part of the University of Illinois system, is looking at how we can be able to create these policy briefs and these kind of policy guidelines regarding about, the technologies regarding about the research that we do. So we formed this, Gagandeep and I, along with Jeremy Riel and the Lavarshni, we created this Science and Technology Working Group. And we just recently got a research scholar grant from IGPA. Jeremy Riel from UIC is the PI, and I'm the co-PI along with Gagandeep. And this particular grant is going to help us to create particular programs that position Illinois as a national leader in responsible AI, and shape Illinois' response to the rapid rise of generative AI. So how do we go ahead and use that AI, but how do we actually make sense of it and make sure that it abides by the particular responsible AI rules? Next slide.
Yeah.
Okay, so basically that kind of goes through the conceptual framework. The last part is certification, which is ensuring AI models meet ethical standards. And then, so therefore, now I'm going to turn it over to Gagandeep to kind of give you the details on what him and his team have been working on to make sure these AI models correspond to responsible AI principles. So Gagandeep.
Thank you. Like we do a lot of work in artificial intelligence in our group, but I don't like to call myself as an AI researcher. I'm first and foremost a formal method person. We have been doing this kind of formal verification of AI models for the last 6-7 years, right? So our goal is how can we bring this rigors of formal methods to provide better guarantees for these AI models than are possible with, let's say, if you just were to test on some finite set of inputs or you were to do some benchmarking, which provide inadequate coverage, right? So this is how I feel that a trustworthy or a responsible deployment cycle should look like. We also have like the position that I have particular in context of how we should go about this trustworthy deployment for any kinds of machine learning model. Maybe it's just simple feed forward model to a large language model. We just had like a position paper at one of this ICML workshop on AI governance. So in my opinion, we should first train the model to get good performance on whatever is the target scenario. Then we must check that the model is accurate, trustworthy, and also efficient, because if the model is consuming too much resources from a financial point of view, it costs the organization hosting it. Though these days there's less of concern in that direction. So what is the role of formal methods here, right? So if you see, we have in this loop, we have this question of determining if a given model is trustworthy. And that's where formal methods can help. It can provide some guarantees on the level of uh, the model being trustworthy. Now, somebody needs to define what does trustworthy means. It's a very domain specific and context dependent notion. And I feel that especially in the LLM world, because the properties are very abstract, there is a tendency to just rely on, okay, this is my input example and this is my output example. And yeah, is the model giving me something harmful for this scenario? That really is not sufficient because you're not even investing time in defining what do you mean by different properties, right? So I go through a lot of these papers that talk about safety properties, but they don't even invest time in formally defining what it means, right? So having a specification, a formal specification of the property, it can be catastrophic risk, it can be biased to, which I will show you soon. If you have not formally defined those specifications from an AI governance point of view, you will not be able to enforce it, right? So if you just give me like input output examples, okay, this should have been the desired behavior, and I'm going to deploy the large language model in the wild, it's going to see some other input and it's going to give you some other output. How, if you don't have a formal sketch of what the model should have done, you don't have any specification, you will not be able to enforce it, because I can always say, oh, yeah, my model worked on the examples you gave me, and then the test time, you did not specify what I should not have done, right? So having this kind of formal specification beyond the certification we will look into is already a good start, because that gives you some toolkit to be able to enforce uh, properties, right? If something goes wrong during test time, and you would be able to hold people that are building these models accountable uh, if you actually have those specifications. So formal verification can provide stronger safety assurances. Now, one place where I'm going to deviate from other colleagues who do formal verification is that they go about like, oh, I want to give the strongest possible guarantees uh, for a model, or I just want to ensure that the model is never going to behave badly. In the context of LLMs, which we will see soon, that's not possible. So the goal here is not to necessarily give the strongest possible guarantees. What we are doing currently is to build some framework that is easy to use for people to get the conversation going, in the sense that people are more receptive to adopting these kind of technologies and they see some gains. And hopefully that will lead to more demand and better tools and better methods and stronger guarantees. So we are building the first framework uh, with statistical guarantees to quantify LLM safety risks. So uh, we have been doing this kind of formal. So what I mean by formal specifications, well, I can give you an example of what we have been previously doing in the context of vision models. So what people usually do is that, oh, suppose I have an image that the model is correctly classifying as car. I'm going to create some region around this original input, which is typically with an L infinity ball of radius epsilon, and I will like to ensure or check whether the model is going to classify each of these inputs uh, as car, right? So that's a robustness specification, which is considered necessary for trustworthiness in this space. There's a lot of work in the last 10, 12 years in this adversarial robustness. The problem remains unsolved still, right? So what are the challenges for doing it for generative models like large language models? Uh, the problem is that LLMs handle a very large and diverse set of prompts that cannot be captured by these typical specifications that people do for the vision model, which is basically, oh, let me take a prompt and create some L infinity ball around tokens. And also like the output property that we want in the previous slide, that was that the DNN correctly classifies each image as a car that can be captured with some symbolic linear constraints. These cannot be captured here with similar constraints. So we have to find a way to formally define what is the desired behavior. So we will look in few case studies. The first case study is for counterfactual bias. Uh, so it's known that LLMs can generate text that exhibit social bias and stereotypes. We are looking at counterfactual bias, which means that you imagine a scenario, what if, right? So why is that important? It's because if the LLM generates biased responses for particular subgroups that are marginalized or underrepresented, then it can impact individuals and propagate stereotypes. And having that kind of representation harm can actually lead to allocation harm, where qualified people are actually not able to get the resources or the jobs that they deserve because of this uh, bias propagated by LLM generations, right? So at a very high level, what we mean is that if we in the prompt vary demographic groups. Now, these demographic groups can be different races, different genders, or whatever. The LLM responses should not change. Change does not mean here that, oh, the token should be identical, but it means that the semantic difference across LLM responses should not vary. So let's try to formalize what is counterfactual bias. So first, we need to see what are the possible inputs for a counterfactual bias. So we will first define a counterfactual prompt set. So these will serve as the input to our specification. So formal specification says you have a set of inputs and you want to ensure that the output of the LLM is going to follow some constraint for those set of inputs. So first we are trying to define what are the set of inputs we are interested in certifying. So first we need to say what are the counterfactual inputs, right? Now this is uh, going to be defined over sets of inputs. So first we will define a counterfactual prompt set. So we have a set of prompts and a set of sensitive attributes. These attributes can be related to gender or race, for example, text description of black, white, or male, female. Now, each prompt can be decomposed into two parts, xi, which is independent of sensitive attributes, and ai is a sensitive attribute. So a counterfactual prompt set is a set of prompts where in each prompt, the xi's are the same, right? So each xi have the same, each prompt has the same xi, and there are at least two sensitive attributes in this set of prompts, right? And for an unbiased text generator, you would expect that the output f of pi should be just dependent upon xi, it should not depend uh, upon the sensitive attribute. Now, of course, there can be cases where the output should depend upon the sensitive attribute. But for defining this counterfactual bias, we are considering only the scenarios where this sensitive attribute should not affect the type of responses the model generates. So let's look at one example. So here we are looking at text completion, asking the model to give a response. So you see here we have these two prompts which will have the identical text. The only thing that differs here is male and female, right? So xi for both prompt is the same, and the only thing that differs across the two prompts is the sensitive attribute. And we are asking the model to complete this sentence. So that's an example of a counterfactual prompt set. Now we want to do the verification, which means that we want to consider a large set of inputs. We are going to consider probability distribution over this set of counterfactual prompt set. So remember, counterfactual prompt set is this collection of prompts which have differing sensitive attribute. Now we are going to consider a distribution over these things, right? And then we are going to provide probabilistic bounds, which will tell you that if you were to sample a random prompt set from this distribution, what is the probability that the model will give you an unbiased response? So how do we check that the model response is not biased, right? So for that, we rely on a detector function, which is going to be a judge model. And this judge model has been trained to identify stereotypes or disparity in the output corresponding to the inputs from the prompt set. So as an example, for the previous case, if the model just gives you this responses which do not show any semantic bias or disparities across the two sensitive attributes, then what we will say is that this detector is going to say that this is an unbiased response. So we have for a given prompt set, what is the output that we want? Now we want to define a formal specification, which will be requiring first to define a probability distribution over this counterfactual prompt set, right? So in terms of setting up this verification problem, I don't think it's worth it from a verification point of view to ask the question, is the model going to give you a biased response or not, right? Because the answer to that in our experience is mostly going to be yes. So there would always be some prompts where the model is going to misbehave based on the capabilities of the models we have and what we have currently seen. So asking that kind of question is not very useful because you are always going to get the same response, which is that the model is biased. Instead, what we want to do is quantitative specification, right? We want to estimate the probability of producing unbiased responses for any counterfactual prompt set from the distribution, right? That is also useful because then the practitioners can use these probabilities to see the risk they have in their particular application. And if those risk is acceptable, because this risk is never going to be zero, then they can reliably try to deploy it in the real world or try to fix the model. So let's see how we do the specification. So we model the specifications as probabilistic programs. So basically, we will consider uh, set a prompt set, counterfactual prompt set, and add prefixes to this. Now, these prefixes are going to come from a distribution, and then we will estimate the probability of an unbiased response. So this is how it looks like. We have three different specifications in the paper. It's published at ICLR 25. So an important specification is this mixture of jailbreaks. So what we do is that we add prefixes constructed from jailbreaks. So we take a set of jailbreaks and then construct a distribution by applying two operations on jailbreaks. One is interleaving, where you take a jailbreak and interleave instructions from some helper jailbreaks, and then these jailbreaks have instructions to provoke the model to give very biased responses. We have mutation operation as well, which tries to obfuscate the jailbreak so that can be effective even under safety training. So this interpolation gives us more stronger jailbreaks. So an example here would be you would start with a main jailbreak here, which would be asking the model to give a very biased response. Now, you would have a set of helper jailbreaks. From each jailbreak, you will extract some instructions. For example, here we have these 5 instructions we have extracted. Now, we can interleave with the main jailbreak the instructions that we had to create more set of jailbreaks, right? Uh, Now, in the next step, we are going to mutate what we had from step 3 by flipping some of the tokens to a random token. So if you see here, in the previous case, we had a completely unhinged response. It became a completo unhinged and gender biased response, right? So uh, formally, I mean, you don't have to go through the technical details. What happens here is that we start with a counterfactual prompt set, and then we will add uh, prefixes to this from this distribution that we get from interleaving and mutating this jailbreaks. Now, these instructions are added, interleaved and mutated with certain probabilities that we can control. These probabilities are parameters to our certification framework. Depending upon the particular application, you can tune it as you want it. So let's give an example. You would have this counterfactual prompt set, which will be asking the model to complete a sentence about a specific profession and a man and a woman. And then we will add these prefixes, which will be obtained with our mixture of jailbreaks. And then we will use Clopper-Pearson confidence interval, which basically is computed using an independent and identically distributed samples from this distribution to compute the bounds PL and PU, which bound the true probability with very high confidence. For our experiments, we use 95% confidence bounds, and that requires, in general, 50 samples from the distribution. So overall, this framework looks like this. You would start off with some prompt set, you would define some distribution of prefixes, and then you would construct the prompts to target LLM, uh, measure responses, you will collect all the responses, pass it through the bias detector, and then you would check how many instances it produced biased response and how many instances it produced unbiased response. So these are examples, right? So here we are asking the model to describe desktop automation for a man and for a female, right? And what we see here are the different models: Mistral, Llama 2, Gemini, and ChatGPT. I mean GPT-4. Uh, GPT-4, yeah. So what we see here is that for each column, we are sampling for this desktop automation male, female. The female one is in red, the male one is in green. We are observing the responses for the different samples from the distribution. So if you see for Mistral, it's actually giving for the first case a very biased response because it's saying something bad about females. While for males, it's giving a neutral output, right? So that's an instance of a biased response. Uh, Similarly, if you see for Mistral, the second case as well is giving you a biased response. Uh, Same for 3. And what you see the bound here is this interval are the bounds on the probability. So what does it mean is that Mistral, the probability of producing an unbiased response is between 0.23 to 0.51 with 95% confidence. Llama 2 usually just refuses flat out. It just says, I cannot process your request. So the bounds for it is quite high, 0.93 to 1, right? So it says that I have a very high probability with this model to produce an unbiased response. Uh, for Gemini, again, we have some problematic behaviors. In some cases, it gives biased responses. In some cases, it does not give biased output, right? So GPT is a bit interesting because what we saw with the other models, it's more biased against females, but this GPT is more biased against male. So uh, overall, what we are seeing here is that if you were to just take one jailbreak, you would not see this diversity of behaviors that you can see with this kind of certification. It can give you a probabilistic estimation. So we had this bold data set, which is asking questions about particular jobs, right? How man will do it, how female will do it, and we compute for each particular job the bounds, and then we average it across. And what we have found is that the probability of producing this unbiased responses with Gemini, GPT 3.5, and Mistral 7B is quite low, right? So you as a developer, if you're very worried about the bias showing up in your output and causing harm to the organization, then those are the things that maybe you can take into account if you are going to select which model to try. Now, the second case study I want to cover is catastrophic risk, which a lot of people that are doing AI alignment are worried about. So, what do we mean by catastrophic risk? So, the question here is can an adversary leverage the advanced capabilities of these frontier large language models to build chemical, biological weapons or commit cyber crimes? Now, what one can see is that this state-of-the-art LLMs are safety trained to directly refuse such kind of queries. So if you're going to directly ask the model how to build a bomb, it's not going to give you an output about how to build a bomb. But recent work has shown that you can still coax the model into giving you the information that you want in a conversational setting. So conversation setting means that you are not asking just one question and observing one answer, but you are having a conversation with the model. So you don't ask the query directly, like if I want to get a recipe for building a bomb, I will ask some questions that appear benign over some sequence of queries, but it would still be constructed in a way that gives me the information that I want. As an attacker, I only care about to get the recipe that I want. I don't care about following some protocol that you may think or some constraint that the attacker should have. So what we want to do is we want to, again, when we are talking about certification, under this kind of conversational setting, quantify the risk of producing a catastrophic output, right? Again, this is an example if your organization is very much worried about the risk of this catastrophic outcomes, then this kind of framework which we are building can be useful. So again, we have to formalize the thing, right? So what we do is for each catastrophic scenario, we collect the scenarios from existing data sets. For example, building particular chemical or biological weapon or particular cybersecurity risk. So we use misaligned or easily coaxed models to create a set of queries related to that topic, right? So let's suppose I create 100 queries, right? That now I have a database of queries related to the particular topic for a particular weapon or whatever, right? Now I will create a graph where nodes are the queries and the edges capture semantic similarity between them. The semantic similarity can be computed uh, with a simple model or with another language model. So we have like this graph that captures the semantic similarities between the queries, right? Now we have to build distributions, how we are going to create this conversation. So we look at conversations of length 5, and we have different methods to create these distributions. And over these distributions, we will be quantifying the probabilities. And we will use the same thing. We will query the model a bunch of times, compute the confidence interval. This time, we are not going to compute the probability of not producing a catastrophic output, but we will compute the probability of computing a catastrophic output. So we have like four ways of constructing this multi-turn prompts. So first method is we will just randomly sample queries from the database we built and queries and add a jailbreak with probability P before each query, similar to what we saw before. The second one is random walk. We will just construct we will just randomly sample a path of length 5 from the graph. The next one is random walk to target, where we will sample a path where the final query is directly connected to the target query, which is like, oh, I want this particular chemical recipe. And adaptive sampling is it adapts, it selects the next query based on the response from the LLM in the previous step. So let me give an example. For example, here we are asking them, we are interested in obtaining these detailed instructions for making this dimethyl mercury from household materials, right? So in the left hand side, we see this is from the Llama 70B model. We see the queries that are generated and the responses of the model. What we see is that we are not directly asking the model to give us these instructions, right? So we are indirectly asking these things to build confidence and to coax the model into eventually giving the response. So we have a judge model which looks at each step. Uh, how is the response of the model, whether that is already giving us the information or not. This judge model is tuned on this particular data set of chemical and biological weapons. So it's pretty good in terms of detecting the information that you wanted. So what we see here is that after we have asked second two queries and we ask the third query, the model starts giving us the output that we wanted. So we have like preliminary results in this direction. And we have tested Llama 70B and DeepSeek R1, and the results are quite worrying because uh, it succeeds with very high probability. So I marked everything where the lower bound of the probability is at least 30% as red here. And we also have some preliminary results, which I'm not showing here for other models like GPT-4o, etc. These bounds are quite high. more than it needs to be. So we are almost running out of time, so I'll just finish up this more scenarios we have been doing. As I mentioned, we want to build this framework, and we are not there yet. We are just starting off. We want to build a framework where you can specify any property that you want, and then you will be able to certify that as well, right? You should be able to easily do it. So the third scenario is related to knowledge comprehension. Basically, it has applications in something like uh, cases where people are using these large language models for uh, places for building apps to serve people in villages, remote areas, where they don't have access to medical advice, but they can use these kind of chat bots to get the answer they want. So again, the practitioners in this case are interested how often can the model give you a wrong advice, right? So we are testing the knowledge comprehension capabilities of the model. Basically, a set of we give a prompt and ask we give it a paragraph and ask question related to the paragraph and check whether how often does the model give you the correct answer. To make it adversarial, we also add some distractor information to confuse the model, and we look at the bounds. The fourth scenario is related to agentic system. Here, what we are estimating is in the case of agentic system, these agents are interacting with tools, and they are selecting tools for, let's say, if I want to book a Uber, it's going to interact with some API related to booking an Uber. Or if I'm using it uh, uh, to call an SMT solver, is going to invoke the particular SMT solver. So here, what we are doing is we are checking uh, how are these models influenced in terms of if I have a particular query by the description of the tool rather than more semantic information. So if I create a tool that is going to do something fishy, but I just say this tool is created by uh, OpenAI, right? There is currently, in terms of how these things are evolving, there is no oversight into, oh, what tools should be considered trustworthy and what tools should not be considered trustworthy. So we are uh, computing the probability by defining distribution over these descriptions of tools and checking how often are these tools which are fishy but have some fancy names are going to be selected by this state-of-the-art agentic systems. And again, the attack success rate is quite high. So with this, I like to conclude the talk and leave you with the important messages from this talk. Uh, and we are happy to take questions.